Now 20 minutes left for our panel, and we keep a high speed to get as much information out from this great knowledge pool that we've collected and invited for this panel. Shravan, I give the floor to you for the next 20-25 minutes. I hope everyone stays with us for the 25 minutes, and I'm looking forward.
Okay, great. So I would like to welcome back Radovan and Jolywood and Jia. Oh, sorry. I think we have Dr. Guo, and then could you please switch on your cameras, and Zheren from Jolywood. Hello and welcome back. Radovan, are you there?
Hello.
Oh,
Hello.
Sorry.
Hi.
Okay, great. Okay, great. As Michael said, probably we have less time, so we would like to go through very, very fast. So yesterday we heard that Qijie is great, and today we heard TOPCon is even greater. And interestingly, a few companies are really working on both Qijie and TOPCon. If both are good, why companies are focusing on both? So they can simply opt for one, right? So who will win? Radovan? Quick answer.
I will win? No. Yes, so maybe I can comment on it. Of course, it's difficult to compare. Certainly N-type will come, but of course TOPCon has many advantages that it's very close to PERC production. So of course, let's say the companies that already know PERC to very much detail, they like TOPCon very much, and the yields and throughput of a PERC line. And I mean, when PERC is improving, then TOPCon is improving. That's the major advantage of the TOPCon technology. Of course, heterojunction, they have a very lean process, but still there are some challenges, let's say, not only on the cell level, which is definitely still the silver, and some other production technologies, but also, let's say, the module is not standard, and there are also few drawbacks there. So I believe that TOPCon will be the next big thing, but definitely heterojunction will be out there. That's my conclusion.
Okay, so Leo, what do you have to say?
Yeah, from my point of view, what I can say is right now from the Jinko manufacturer, what we can improve is just from the PERC to the TOPCon is we can improve the yield, we can and also the equipment, the manufacturer's cost is getting lower and lower, and that is two kind of very main reasons. That is why we transfer from the PERC to TOPCon. But as we can see that the HGT is more cost, we need to pay more cost on the HGT because its technology need to be in a very specific environment to make such a kind of product. And we, the very important thing is we need to make it, how to say, this is a scaled economy. That is very important for us to push forward. That is why we believe that the TOPCon will be the next 3 years to 5 years main product in the market. Yeah.
Okay. So, Qijie, because you are also working on both the directions, so heterojunction and TOPCon. So, what's your take on this?
I think I would agree with what just kind of like agree with Neil and as what just mentioned, right? So I think for the TOPCon, right, it's in the short term, in the next few years, it's a natural upgrade to the PERC, right, to really extract the values that we have already invested in the manufacturing of the PERC, right? And so I think, to really improve the the cost structure. So for HAT, it's from the self-engineering, from the cell perspective, it provides a high efficiency. I think both because of the passivation quality, right? For the I think from the engineering perspective, it has the potential for higher cell efficiency. So it's from that perspective, it's it's a very good technology. But the issue there is the capital investment that's required. So we are waiting for some of the tool manufacturers to really to start kind of like what happened with the P-type technology, right? The economy of scale. I think that's what's really it's needed. And then metallization cost is a big thing for PERC. I think for HAT. I think but there are some exciting developments in terms of cost-effective metallizations like plating or copper, silver cobalt copper. So I think those are some exciting development that's there. I think when all the pieces of puzzles are ready, I think HAT will become a very compelling investment. But for in the short term, I think TOPCon, because of the investment requirement, as well as just to extend the already invested capital, right, to extract the value out of the PERC and the PERC investments. I think TOPCon will be in the short term, I think will be the winner.
Okay. So you are anyway a very strong proponent of TOPCon, so I would not ask this question, but since Jolywood is really is spearheading the TOPCon development, but where do you see the TOPCon overall segment is going to grow by end of this year and next year?
Actually, just now regarding the two technology, actually, we think both technology are very good. It's not that Jolywood only focus on the TOPCon, which means that actually is not good for us. Actually, we also have we also learn from HAT. For example, we also use some technologies that is already being used in HAT. I think it's, actually the progress of HAT also helps the progress for TOPCon. And just now what you mentioned about the the sector of the TOPCon. Well, which sector of the TOPCon would grow?
So how much do you think would be the capacity for the TOPCon by end of this year and next year? So for example, in heterojunction, the capacities are announced big, but they never realized in reality. So what do you think for the TOPCon?
Okay, I think by the end of this year, I think the capacity will be maybe around 4 to 5 gigawatts based on our current information. And maybe for the next year, the prediction may be about 40 to 50 gigawatts. But information actually is based on some of the Chinese institutes and research organizations. So that's what we know for now. Yeah.
Okay. And Leo, what do you think?
Yeah, yeah, it is a very good question. And from my point of view, the idea is in the end of this year, the TOPCon will be 14 around the TOPCon technology, and from the next years, as Mr. Du said, we have the same idea that we can focus on the 40 to 50, but on 2023 to 2024, it will be reach more than 100 gigawatt, for sure. Yeah.
Wow. Okay. Radovan?
Yes, of course. I mean, the total capacity will grow, and I maybe will rather give a forecast when we enter the terawatt market in 2030.
Okay.
Then everything will be N-type, hopefully. But no, let's say I completely agree with my Chinese colleagues because they have a much better insight than I do.
Okay. TOPCon has, yeah.
But let me mention maybe one thing. But Zheren was saying, yes, we can learn from each other, and I think that's the best way we can also cooperate. And as Mr. Guo was saying, I think at the end it will be amorphous on polysilicon IBC that makes the race, because then we can get most of the energy out of bifacial IBC. It can be also bifacial, by the way. So that will be the holy grail, I think, that everybody will reach in the next 5 to 6 years, maybe 7. Yeah.
Okay, so almost everyone said TOPCon has been considered as a line of extension for PERC and is expected to take off very soon. As soon as PERC reaches its efficiency limit, of course, at least on the commercial level, it seems to have reached not the limit, but I think it's a little stagnated. But there were also several announcements, and still, like we are not reaching very great production capacities, at least by end of this year. So, what is still the main challenge, if there is any, that has to be addressed with TOPCon? Radovan, you can start.
Yes, this is very similar what happened with the change from aluminum black surface field to PERC. I think it's the tool, and as soon as the PCVD or APCVD or PVD tool will reach really a great matureness level, like high throughput and good homogeneity, then it will go very fast, I believe. And at this point, I would say silver is still not a big pressure to go to copper, because we heard we have very good fine line printing processes, and so actually the TOPCon metallization will be not double the PERC in future. Of course, we will reduce the silver dramatically also by fine line screen printing, but we need the tool. And that's certainly, I would bet, at the moment on the PCVD deposition tool from Centrotherm that we are cooperating with.
Okay, so that means you think everything is being addressed?
Yes, I mean, of course, the N-type wafers are a big thing, because in 2016, when Longi brought the good P-type mono in place, that this was the breakthrough for PERC, because then the advantage in the mono was visible on PERC level, and then it went quite fast. So it's the tool, N-type wafer, but I think N-type wafer is now a no-brainer. Longi can do very well, because they can do also, let's say, gallium doped wafer. So N-type is even easier. Of course, the polysilicon has to be a little bit cleaner, but this is also not an issue. And metallization, fine line printing is there as well. So these are the 3 major points, and I think the tool, the PCVD deposition, really is the key at the moment, like it was with ALOX for PERC.
Okay. And so what do you think, Leo? Are there any bottlenecks?
From my point of view, is just as I said, it is cost effectively which kind of technology we will use to get a lower cost realization. But what we can nearly say that this is how we can make it, and the second one is which one we can get a much higher yield to make such a TOPCon. What I can say is right now, whatever we use, we have tried many kind of technology, but still, like, we are trying to find a good way to make it better. Yeah.
And Zheren?
Yeah. Actually, for TOPCon, I don't worry about the efficiency, or I don't worry about the yield as well. What I'm maybe a little conservative about the cost, because it's always like more silver consumption compared with PERC. Although maybe we can use the laser transfer printing on the front side. It can be done also by PERC. So we have to reduce the difference or the silver consumption. I think Jinko has done a very good progress. I think they are very aggressive on the silver consumption. So that's what I heard from my colleagues. Yeah. So I think in the very near future, the silver consumption definitely will be greatly reduced. And another way to reduce silver consumption, not only by the laydown, but also we can try some of the other materials, for example, the aluminum or copper to substitute silver. Yeah, that's what we are also trying to develop this new material technology. Yeah.
Okay, then a question to Qijie. So we have seen the silver. The silver there is a possibility of replacing silver with copper-coated silver particles for heterojunction, and there is, as you know, there is already a lot is happening. So do you see something similar to that can also happen for the TOPCon, because that's a low temperature queued and this is a high temperature queued? So are there any fundamental limitations from the paste side?
Yeah, so it's a very good question. This silver issue came up from time to time, and Solamet, we looked to it for a long time, right? So the main issue here is the high temperature firing process. It's done in air, so the issues there with all the base metal is they get oxidized, right? So they lose the conductivity. And so there are a few ways to, and then the other part is, so there are a few ways to maybe to go around it. So if the cost really come to a pinch, then you can consider like a inert firing, then you can use a base metal in that case, and as a for the front side finger. Now, if we are limited with the process technology, right, in terms of investment, then there are ways to do in terms of self-engineering side. So for example, if we can do the TOPCon, if the wafer quality is great, we can do a rear junction TOPCon. And then the limitations of the silver, and then you can put aluminum paste instead, right? Just flip it, right? So that's one approach. Because the current way with the metallization for the aluminum silver paste is not only because of the contact, it's also the requirement to conduct the electricity, right, in the grid resistance. So if you flip it with a rear junction, that's one, I think, exciting a potential approach, right? And then talk about earlier, if you go with a back contact, then you have more options to internal metallization. So I think, and those are the ways we can do, but those will be the step changes in terms of metallization, silver consumption reduction. In the meantime, then we're working on its incremental reductions, right, with the screen optimization, with the fine line printing, to really squeeze out every little bit of the silver out of it. So that's something we can do, but to really on a step change, that really need to work with the cell maker instead of redesigning the cell.
Okay. So then one question regarding the deposition technologies. Now, everyone is saying they are able to get through some good efficiencies and everything. Everyone has their own claim of going to higher efficiencies. But Radovan, since you are a researcher, what do you think is the best quality for a TOPCon cell? Which production equipment can provide the best quality, and also cost performance ratio?
Exactly. So to my understanding, LPCVD gives extremely high quality layers, but let's say this is not the way to go, because we know the disadvantages of LPCVD, and then we have to have higher throughput, lower standing time and things like that. So that's why we are going to PCVD to make the diffusion one-sided and some little bit cannibalize the efficiency, but not in future, because PCVD can be also powerful. But what I mentioned in my presentation is, in order to increase efficiency, then later we have to go to selectivity on the front side, either we have introduced the selfie concept, or this has been mentioned also many times, go to back contact, and then you can do anything you want on the rear side. But I would still keep bifaciality, because that gives you an additional advantage still. Yeah. And that's possible.
Okay. Leo?
Yeah, yeah. I totally agree with Radovan. Yeah, LPCVD is a main kind of like technology among the Chinese solar manufacturer, and the idea is compared with the PVD and the PECVD, and we can see that of course they have advantage of high yield, but the equipment is higher. But to lead to a very, I'm not sure that the product will be, the price will be higher or not higher. But at least this LPCVD is a very, very mature production line, and its control is also not very difficult. That is why we, from my point, is LPCVD. Yeah.
Okay, so Zheren, you have worked on LPCVD. Now you move to PVD, but have you also evaluated PECVD? Is it lack of the PECVD in the market? So this question is to Zheren from Jolywood. Sorry.
Yeah. So actually, we think that all these technology have their own advantage. For example, LPCVD is really widely used. It's really very mature technology. So it's maybe it's the most stable choice. And actually for Jolywood, why we skip PECVD and we go straight to like PVD similar technology. And the reason is that we think the most important thing for the TOPCon is the process steps. And even for PECVD, and we did some test runs, and we know that there's still a little bit wraparound. We still need wraparound removal. That's why we are looking into new technology, for example, PVD, like this kind of technology, and that's why we focus more on this. I think the fewer number of steps is definitely beneficial for yield and also efficiency, and most importantly the cost. That's the reason that we skip PECVD and we go straight to PVD. Yeah.
Okay. Qijie, since a lot of people always blame, especially the deposition equipment people, their deposition mostly depends on the metallization. So probably you might have worked with everything. So what is your experience?
Well, I think sorry, it was a little bit lag, but I don't know if I heard the question right. So you think the deposition a lot depends on the metallization, right?
I think, at least deposition, people say, we are not limited by, whatever the film stoichiometry or the thickness, this all has to do with the metallization. That's what they simply say. So.
Right. I think, I understand that, definitely there is still, room to improve for the metallization, right? And metallization is a key part of it, right? So I think something Radovan mentioned earlier, the tools is very important. Because the metallization, has to be able to accommodate for the whole process, the one step, right? It has to be accommodate for all the non-uniformities that's in the process. And so that sometimes it's a balancing act, right? For us, it's a balancing act. For example, if you have wraparound issue, if you have poly non-uniformity issues, if you have different textures or different, so all those it's a balancing act for us in terms of metallization. So of course, we'll love to be able to have a very uniform substrate to work on and then be able to optimize the pace for it. I think that's doable. But I think given the limitations of the current tools, I think we are basically also somewhat limited. Now, there are challenges there for metallization, of course. For example, how do you enable thinner poly, right? Because that has an impact in terms of the throughput. And that is still it's doable. It's not perfect, right? So, but I think, in a way, once the tools are ready, with the knowledge that we have, accumulate over the years, I think I think the problem can be solved.
Okay, So I think we are also running out of the time. I'll have one final question. Like, you know, TOPCon, the next step is, a lot of people are saying, okay, you can go to IBC, then tandem architecture. So what would be the most probable way? So will TOPCon make a direct jump from TOPCon to tandem architecture, or it has to go from first IBC and then goes to tandem? Radovan?
Okay. So of course we are always now talking utility scale, right? Because the whole market is not utility scale. It's also building integration and rooftop, and it has also to do with some aesthetic issues. So IBC is certainly the way to go for that, and that will be also a huge gigawatt market. So it's not either or. I think that there will be both-sided contacted cells out there for a long time, but IBC will come as well, and mainly because of building integration and rooftop applications. But then, and I repeat myself, is that I believe that the final step is, for crystalline silicon at least, is an IBC cell, low-cost IBC cell, and because with that, the front side is still the most important side. Even if you cannibalize the bifaciality, of course, the front side is you have to go for, and there you have no metal. So at the end, crystalline silicon IBC will win. And then, of course, we can go also to 3 and 4 terminal because of the IBC.
Okay. Leo?
You're muted.
Yeah, as far as I know that if we look back on how do we transfer from the PERC to TOPCon, and you know the production line of the TOPCon and PERC will be updated from the traditional one of the PERC, so which will have a significant positive effect on the initial investment. But AGT, as a publicity report, as I said, it's a simpler production process, but it is incompatible with the existing production line at the cost. And the directly result is increases the equipment cost. As I said, it is a lot of money, right, on gigawatt. So if we look in the very, very few future, how IBC, whatever, I don't think that if the equipment, all the costs will be getting lower and lower, and also the customers will also accept this kind of technology. I think everything will be possible in the coming far future. Yeah. This is my point of view. Yeah.
Shravan, you're muted.
Sorry, Darren from Jolywood. So what do you think?
Yeah, I think I agree with Radovan. And I think the IBC cell is definitely one of the fantastic cell structure that will be one of the ultimate cell structure. I don't think it will be skipping the TBC or HPC just really directly to tandem, because tandem still, I think, still needs some time to develop. So TBC actually is one of the best choice for the next generation, and actually Jolywood is also actually already started some of the research on this new cell structure, and also according to our technology roadmap, I think this TBC is definitely is the next candidate. Yeah.
Okay. So finally, you, Qijie.
Yeah, so so I think it's a great question. I think the other speakers already kind of like, we all similar on the same page, right? So just speaking more from the technology readiness, right? In terms of the tools that's available, I think IBC has the tools ready. It's just the integration as well as getting the maturization, right? So it's building a very fantastic TOPCon platform. So I think it's a natural next step upgrade, right? And the tandem, it's exciting. I personally work on perovskite PV myself. I know it's a very interesting, exciting material, but there are still challenges with it, right? So I think to be able to put it in terms of integrated, especially from the 2-terminal, I think that's even more challenging for the 2-terminal being able to integrate it. I can imagine maybe integrated with the HAT, right? With the TCO there, do a 2-terminal integration, maybe feasible in terms of building all the costs already there for the HAT. But if you integrate it with the TOPCon, the different processing, the cost to integrate it into 2-terminal, it's going to be phenomenally high. So I think for HAT, I think it's a good case to demonstrate the tandem, as a possibility to demonstrate its value, and then maybe later it could be combined with the IBC for the 4-terminal to really be able to extract the maximum. That's how I will imagine it.
Okay, I think this is a nice closing remark that so soon we will also see IBC as an upgrade for the TOPCon. Radovan, you should be very happy.
Yes, I'm looking forward for the 4th day of TaiyangNews again.
Hopefully we will do it next year. Hopefully. Okay, Michael, thank you very much for everyone for contributing such a great, lively discussion. And I think Michael will give the closing remarks.
Okay,
Michael,
thanks. Okay, thanks to everyone. Radovan, good point. I think we'll keep that actually on our list that next year we will have an IBC day again. I think over 2 years enough will have been also accumulated to fill that day. And we're 1 year ahead, so there will be probably also some more progress. Okay, so we're coming to an end. That was our final event. So thanks a lot to you, our panelists, our speakers, doing such a great jobs. Thanks to our sponsors. Thanks to the attendees. Over the course of the 3 days, we had registrations from 1,000 people. Many of them participated. We have several reports which you can download. The TOPCon report is actually also available in Chinese. We launched it also last week during the CSPV event in China, which took place also physically and where we organized a session. And we are coming out with a couple of more reports until the end of the year. That leaves me only to say thanks again. We wish you Merry Christmas, happy season holidays, take some rest. I think it was a busy year, but if we look into the crystal ball, it will be only getting busier. There's a lot coming up with prices being a bit on the high side and everyone hoping that it goes somewhat more to normal, at least in the second half of next year. We will get lots of deployments and a big rush also when we're seeing all these climate change related based new and higher targets in many parts of the world. So again, get some rest and then see you again next year, hopefully with TaiyangNews. Bye-bye.